Hello, this is Dr. Hanaa Assil, and this is Combined Science, paper 4 of June 17. This is version 1. This is IGCSE Combined Science Cambridge. So the first question said, use lines to connect the box on the left to different boxes on the right to make correct sentences. One is done for you. The sentence reads, flowering plants need oxygen for germination of seeds. Draw 3 more lines to make 3 more correct statements. So, what do we know about flowering plants? Well, do they produce haploid pollen? Yes, they produce pollen grains that have half the number of chromosomes, so that is correct. They lose water from leaves by perspiration? No, they lose water from leaves by transpiration. Transport sugar through the xylem? No, they transport sugar through the phloem. It is water that is transported through the xylem. Use auxins to respond to light? Yes, they use auxins to respond to light. They need oxygen for photosynthesis? No, they need carbon dioxide for photosynthesis. The oxygen is needed for respiration. They have root hair cells which increase water uptake? Yes, they have root hair cells that increase water uptake. So these are the 3 statements that are correct. Figure 1.1 is a diagram of a wind-pollinated flower. Describe how the following structures make the flower suitable for wind pollination. So the anthers, how are they adapted to wind pollination? You should see and you should know actually that they are long and hanging out to allow the wind to pick up the pollen grains. What about the stigma? The stigmas are long and feathery in order to collect the pollen grains from the wind. So just one reason why wind-pollinated crops are grown close together by farmers. So the plants need to be near to each other in order for pollination to occur. So this allows more chance of pollination. Do you remember what is pollination? Pollination is the transfer of pollen grains from anther to stigma. So when the plants are near to each other, then there is more chance that this will happen. The growth of crops can be reduced by acid rain. Describe how burning fossil fuels can lead to acid rain. How is it that burning fossil fuels causes acid rain? Remember that fossil fuels have sulfur impurities. So when burned, the sulfur is oxidized and becomes sulfur dioxide. And this sulfur dioxide goes up into the air, it dissolves in rainwater to form acid rain. So just how acid rain reduces the rate of growth of crops. Remember, he's not telling you what is the effect of acid rain on crops. He already tells me that the acid rain reduces the rate of growth of crops. Now, how does it do that? It denatures the enzymes in the plant cells. Remember that acid rain has low pH, and that causes the enzymes to be denatured. Figure 2.1 is a dot and cross diagram to show the outer shell electrons in a molecule of hydrogen chloride. So we can see that there is sharing of electrons. So what is the type of bond that is shown when we have sharing of electrons between two nonmetals? Then this is a covalent bond. Draw a dot and cross diagram to show the outer shell electrons in a molecule of methane. Methane is something that has 1 carbon, 4 hydrogens. And that means the carbon is in group 4. It has 4 electrons in its outer shell. It needs 4 more electrons, so it's going to share a pair of electrons with each hydrogen. Now, each hydrogen has 1 electron of its own. And remember, this electron is in the first energy level. it takes only 2 electrons, so the hydrogen has 1 and it needs 1. And this would be the dot and cross diagram for methane. Name the 2 products of the complete combustion of methane. When we have complete combustion of any organic compound, it gives carbon dioxide and water. Remember, if it were incomplete, it would give what? It would give carbon monoxide and water. Then he says, explain in terms of energy changes why methane is used as a fuel. Remember that a fuel is something that releases energy or releases heat, and this in terms of energy changes, when we say that something gives out heat or releases heat, that means that it is converting chemical energy to thermal energy. So when he says describe anything in terms of energy changes, so you need to tell me it is changing which kind of energy to which kind of energy. Remember that fuels or food or cells, for example, they contain chemical energy. Now, when they burn and release heat, this chemical energy is converted to thermal energy. Methane is the main constituent of one fossil fuel. State the name of this fossil fuel. Which fuel is mainly methane? You should know that natural gas is mainly about 93% of it is methane. State the names of 2 other fossil fuels. So we have fossil fuels are natural gas or coal or petroleum. Remember that coal is a solid fossil fuel, petroleum is a liquid fossil fuel, and natural gas is a gaseous fossil fuel. Okay, this question says figure 3.1 shows a windsurfer on a surfboard driven by the wind sailing at a constant speed across the sea. So it is moving. Can you see the direction of the wind? The direction of travel at constant speed. The arrows labeled A, B, C, and D show the forces acting on the surfboard. State which letter corresponds to friction. So if the force board is moving towards the left, then where is the friction? The friction is in the opposite direction, so that would be D. What about upthrust? What is upthrust? Upthrust is the force from the water that is pushing the force board up. So C is the upthrust. Force A is measured and found to be 1200 Newton. Can you see A? State whether C is 1200 Newton or has a different value. Remember that he's moving to the left at constant speed. He's not going up or down. So that means C should be the same as A. So A and C are 1200 Newton since these forces are balanced. Remember, he's saying state and give a reason. The surfboard travels at constant speed of 2 meters per second. Then the wind speed increases and the surfboard moves with an acceleration that is not constant until the surfboard reaches a constant speed of 4.5 meters per second after 10 seconds. Sketch the shape of the speed time graph of the motion of the surfboard from the time the wind speed increases until just after the constant speed of 4.5 meters per second. So what did he say? He says the surfboard moves with an acceleration that's not constant. So something like this until it reaches 10 seconds and then it becomes constant at 4.5 meters per second. So your graph should look something like this. The kinetic energy of the wind provides the work needed to move the surfboard across the sea. The mass of the surfboard and surfer is 120 kilograms. Calculate the kinetic energy of the surfboard and surfer when they are moving at 3 meters per second. How do we calculate kinetic energy? You should know that kinetic energy is half mv squared. Half times mass times speed to the power 2. So, half times the mass is 120, the speed is 3 meters per second to the power 2. That gives me 540 in joules. The wind transfers 90 kilojoule of energy to the surfboard when moving it along at 3 meters per second for 50 seconds. Use the work done by the wind to calculate the driving force of the wind. State any formula you use and show your work. So we want to calculate force, and force needs distance in order to be calculated. So we need to calculate distance first. How do we calculate the distance moved? You know that velocity is distance over time, so the distance is the velocity times time. So that's the speed, which is 3 times the time, 50 seconds. The distance is 150 meters. And then what does he want me to calculate? Force. Force is work over distance. So the work is 90 kilojoules. I need to change it to joules. Multiply by 1,000 over the distance in meters. This gives me the force in Newton. Please make sure you memorize the basic equations that are needed in order to calculate the required questions in physics. Figure 4.1 shows a drawing of a single-celled organism called Euglena, as seen using a light microscope. This organism has features of both plants and animals. Chloroplasts are usually found in plant cells. Describe in detail the function of chloroplasts. So what is the function of chloroplasts in a plant cell? You should realize that the chloroplast contains chlorophyll. Chlorophyll traps light energy and converts it to chemical energy to be used in photosynthesis to react carbon dioxide and water to give glucose and oxygen. So that's the function of chloroplasts. Name one feature of Euglena you would more likely see in an animal than a plant cell. So which of these you'd not see in a plant cell? Obviously, can you see the flagellum? It needs the flagellum for movement, and you cannot find a plant cell that has something to help it for movement. Figure 4.2 shows an aquatic food web. Phytoplankton are microscopic plants that float on the surface of water. Zooplankton are very small animals. Use this figure to draw a food chain containing 5 organisms, including the crab. Remember that when he gives you a food web and he says draw a food chain, you have to start from the producer, from the one that is lower in the food web, to the final consumer way up there. You cannot stop in the middle. So I have to start with either seaweed or phytoplankton, and I have to end up with seagull. So he wants 5 organisms and he wants to include the crab. So going this way, it will be phytoplankton, zooplankton, mussel, crab, seagull. And remember, the arrow is going from the organism that is being eaten to the organism that's eating it. And that is because the arrow shows the flow of energy from one organism to the next. The chemical energy contained in the producers is transferred through the food web to the seagull. Suggest why the seagull gets more energy transferred from the phytoplankton by eating mussels rather than fish. Okay, so if you look at the food web, we're going through phytoplankton, mussel, seagull. Can you see that? Phytoplankton, mussel, seagull. But if I go through the fish, then I have to go through zooplankton, small invertebrates, fish, and then seagull. You should realize that the one through the mussel is a shorter food chain. The food chain through the mussels is shorter. This means less trophic levels, less loss of energy. Remember, as we go from one organism to the next, there is loss in energy. So if we go through several organisms, we lose a lot of energy, much more than in a shorter food chain. A student investigates the reaction between dilute sulfuric acid and excess copper carbonate powder. The apparatus she uses is shown. The reaction produces a gas, which is collected in a gas syringe. A salt and another compound are also produced. Describe the pH change, if any, of the reaction mixture and name this type of reaction. What is happening? We have copper carbonate, but we have in solution, we have dilute sulfuric acid. So at the beginning, we're starting with acid. So the pH would change from low pH of acid, which would be 1 or 2, to the neutral pH, which is 7. So this is called a neutralization reaction. Complete the balance symbol equation for the reaction between dilute sulfuric acid and copper carbonate. Now you should know acid plus carbonate should give what? It should give some sort of salt. So in this case, it is copper sulfate plus carbon dioxide plus water. Please remember to check to see if this is balanced or not. Is this balanced as it is or not? Yes, it is balanced, so I can move on. Copper carbonate is insoluble in water. The salt which is produced in this reaction is soluble. So if we put copper carbonate, it is not soluble, but as it reacts, it will dissolve. So just the method of making pure dry crystals of this salt from the mixture that is left after the reaction is complete. Remember, what did we do? We added excess copper carbonate to the acid. So it reacted, but some of the excess copper carbonate remained. So first I need to filter through filter paper and funnel in order to get rid of the excess copper carbonate. Then I need to take the filtrate, heat to point of crystallization. Then I need to cool after heating in order to form crystals, and then we filter the crystals. Okay, so this is how we prepare a salt when starting with excess solid plus acid. The student records the volume of gas in the syringe for 10 minutes. Describe how the shape of the graph shows the change in the rate of the reaction. How the shape of the graph shows the change in the rate. So you need to mention something about how the rate is changing and how the shape of the graph shows that. So first of all, you can see that the slope decreases with time and then levels off. So that indicates that the rate decreases and then the reaction stops. Remember, for any reaction, at the very beginning it's fast, but then the rate decreases as the reactants are being used up. So as the sulfuric acid, for example, is being used up, then the rate decreases until no more sulfuric acid. So the reaction stops, no more gas is given off, and the volume levels off. She repeats the experiment using the same volume of less concentrated sulfuric acid. Remember that the sulfuric acid was the limiting reagent. We had a lot of the carbonate. So if I'm using less concentrated sulfuric acid, that means the rate will be slower, and that means it will start to level up later than the 4 minutes of the first experiment. And also it will level up at a lower volume of gas because I have less sulfuric acid. So it will produce in the end less volume of gas. If it were concentrate sulfuric acid, but the acid was excess, then it would not affect the final volume of gas. Explain in terms of particle collisions the effect of using less concentrated on the rate. Why is it that when we use less concentrated acid, the rate decreases? Well, this is because when you have less concentration, that means less particles, so less collisions per second. Remember, rate is collisions per time. Figure 6.1 shows a man standing in the sea on a sunny day. The man says that his back is getting too hot in the sun. Explain why wearing a white shirt can prevent the temperature of his back from increasing. So when he wears a white shirt, what happens? The white reflects the radiation from the sun, so less heat is absorbed onto his skin, so he will not feel that hot. The temperature of the man's body is 37 degrees Celsius. The temperature of the sea water is 15. Explain why the man says that the water feels cold to his feet. Well, remember, if we have the man's body next to the sea water, then the heat is transferred from the warm body to the colder water. Remember, heat is transferred from warmer objects to colder objects, and that means his feet will feel cold. The man walks out of the sea, and his wet feet slowly become dry. He says that his feet get colder as they dry. Complete the sentences below that explains, in terms of movement of molecules, why his feet get colder as they dry. Of course, they dry, that means the water evaporates. So we're talking about evaporation here, and we said when water evaporates from liquid to gas, then the more energetic water molecules which are on the surface of the water will escape. This means that the remaining water molecules have less energy, so the remaining water on his feet will have lower temperature. Remember that evaporation causes the remaining water to have a lower temperature or to cool down because some of the energy has been used to evaporate the molecules on the surface. Figure 6.2 shows a man spear fishing. He sees a fish in the sea in front of him. He says that the fish appears to be near the surface. The man thinks the fish is at point F. Draw a ray diagram to show where the fish really is. Mark this point with a letter X. So if he's looking from air to water, what is happening? The fish is actually lower at X, but as the ray comes from X to the surface between the air and water, it refracts going to his eyes, so he's seeing the extension of that refracted ray, and that is why he sees it as if it is at F, not at X. The man cooks his fish in a microwave oven. On figure 6.3, place microwaves in their correct position in the incomplete electromagnetic spectrum. Do you remember what the electromagnetic spectrum was? This was this. Gamma rays, X-rays, UV, visible, infrared, and microwaves are just before the radio waves. Microwaves travel at a speed of 3 times 10 to the 8 meter per second. The wavelength of the microwaves used is 0.12 meter. Calculate the frequency of the microwaves used. State the formula and show your working. So, I want to calculate frequency. Frequency is speed over wavelength. So, the speed is 3 times 10 to the 8. He says the wavelength is 0.12, and this gives me the frequency in hertz. Table 7.1 shows the mass of some of the contents of 3 foods in a 100-gram sample of each food. So in a 100-gram of bread, I have this amount of fat and carbohydrate and protein and water and so on. And he's saying the energy for the body provided by 1 gram of each nutrient is shown. So 1 gram of fat has 37 kilojoules, 1 gram of carbohydrates, and so on. A student cooked a meal using 200 grams of eggs. Use the information in the table to calculate the energy provided by the 200 grams of eggs. Remember that the information in the table is number of grams in 100 gram of the food. So I have 200 grams of eggs. So I will have twice these number of grams of fat and carbohydrate and proteins. And each gram will give this amount of energy that he gives me. So what we have is, we have 37 kilojoules provided by 11 grams plus 1 gram of carbohydrates has 17 kilojoules plus 13 grams of protein have 17 kilojoules. This gives me the amount in 100 grams. He wants them in 200, so this will be the amount in kilojoules. A person has a family history of coronary heart disease, and it is likely that he will develop the condition too. State which food listed in the table he should avoid. Which of these would be likely to lead to coronary heart disease? Of course, coronary heart disease is due to accumulation of fat. So the one that has more fat is the one he should avoid. Which one has more fat? That is eggs. It has higher amount of fat, so this is the one that is more likely to lead to coronary heart disease. The energy from food is released by respiration. Complete the balanced symbol equation for respiration. So you should know that respiration is glucose plus oxygen to give carbon dioxide plus water, and this is the balanced equation. Describe how oxygen is transported in the blood. How is oxygen transported in the blood? It is attached to hemoglobin in red blood cells, and these are carried in the blood plasma, which is the liquid part of the blood. So the red blood cells are floating in the plasma. They have hemoglobin. The oxygen attaches to the hemoglobin in the red blood cells. Fats, carbohydrates, and proteins are made up from large molecules. They have to be broken down by chemical digestion into small molecules. Name the areas of the alimentary canal where chemical digestion happens. So in the alimentary canal, where do we have chemical digestion? Remember, chemical digestion is the one that requires enzymes. So where are enzymes working in the alimentary canal? In the mouth, I have saliva that contains amylase enzymes. The stomach contains pepsin that breaks down proteins. And in the duodenum, which is the first part of the small intestine, we also have enzymes. So chemical digestion happens in all of these. Now, where does absorption happen? Remember that all the digested food is absorbed into the blood in the second part of the small intestine, which is the ileum. Use the periodic table to determine the electronic structure of an aluminium atom. Of course, if you look at the periodic table, the aluminium is in group 3. It has a small number, atomic number 13, and mass number 27. Electronic structure means you're going to distribute the number of electrons. Of course, this means it has 13 electrons. The first shell takes 2. The second shell can take up to 8, not more than that. And the rest goes into the third shell. So that total is 13 electrons. Aluminium is extracted from aluminium oxide by electrolysis. Aluminium oxide contains aluminium ions and oxide ions. Name the product of electrolysis at the anode. You remember that anode is the positive electrode. Which of these will go to the positive? It is the oxide ion. The oxide ion goes to the positive and reacts to form what? To form oxygen gas. So the aluminium is collected at the negative cathode, and the oxygen gas, that is the one that is formed at the positive anode. Describe in terms of atoms, ions, and electrons the reaction that takes place at the cathode. What is happening at the cathode? You should realize that the positive ions, which is aluminium, they go to the cathode to gain electrons. So the aluminium 3 plus will gain 3 electrons and become aluminium atoms. Iron is extracted from iron 3 oxide in a blast furnace. Name a substance that reduces iron 3 oxide in this process. So in the blast furnace, what reduces the iron 3 oxide to iron? Remember that the iron 3 oxide reacts with carbon monoxide that is formed in the blast furnace to be reduced to form iron. Explain why aluminium cannot be extracted from aluminium oxide in a blast furnace. Remember, in a blast furnace, we cannot extract aluminium. This is because aluminium is more reactive than carbon, so it cannot be displaced by carbon. A student investigates the reactions between aluminium and solutions of metal sulfates. When a freshly cleaned piece of aluminium is placed into a solution of magnesium sulfate, no change is seen. Remember that if you put a less reactive metal like aluminium with the salt of a more reactive metal, it doesn't react. So if you look at the reactivity series, only metals above or more reactive can displace the metals below. So if I put aluminium in magnesium sulfate, it doesn't react because aluminium is less reactive than magnesium, so it cannot displace. When a freshly cleaned piece of aluminium is placed into a solution of copper sulfate, the surface of the aluminium turns brown. So in this case, aluminium with copper sulfate reacts. This is because aluminium is more reactive than copper. It is above copper in the electrochemical series, so it will displace it. So aluminium is more reactive than copper, so it displaces the copper. Figure 9.1 shows a simple test circuit for testing different materials to see how well they conduct electricity. The material being tested is connected between X and Y. Name two materials rather than copper that would be found to be good conductors when tested. Which type of materials are good conductors of electricity? Well, they should be metals, or the only non-metal that conducts electricity is graphite. Otherwise, any other metal, aluminium, zinc, any metal would conduct electricity. A piece of copper wire is connected between X and Y, and a voltmeter is connected in parallel to resistor R. The ammeter reads 0.5 ampere, the voltmeter reads 2 volts. Use the formula resistance is equal to voltage over current to calculate the resistance of R. So how do we get calculation of R? The voltage, he already tells me it's 2. The current is 0.5 amperes. So this gives me the resistance in ohms. Two pieces of wire, P and Q, with the same length and made of the same alloy are connected in parallel between X and Y. So we have something like this. Two wires, P and Q, connected between X and Y in parallel. The current in wire P is 5 amperes and the ammeter is 7. Remember that the ammeter up there is reading the total current going through the circuit, so that is 7. Now, if I have two wires P and Q in parallel, the current divides. So if one of them is 5, then the other is 2 amperes because the total current is 7 amperes. So P plus Q is 7. If P is 5, then Q is 2 amperes. Deduce why different currents flow in wires P and Q. Give reasons for your answer. Remember that different currents will flow whether there is longer or shorter wire. So if one of them is longer than the other, then the longer one will have more resistance, less current flowing through it. Or one of them could have a bigger cross section than the other, and the one that has the bigger cross section will allow more current because it has less resistance. But he said that P and Q have the same length, so the difference between them must be that one is thicker than the other. So the one that has more current flowing through it is the thicker wire because it has less resistance. Okay, so that's the end of this paper. I hope this was useful to you. Thank you for listening, and please continue listening to the videos. Thank you.